The next line, so what does it really mean when we can reach to this particular line? If we can reach to this particular line, that means the following. That means this part here is actually false, which means they are not pointing to the same objects. And also this part over here is also false, meaning that object is not equal to null. And also this part here is also false, meaning that this and objects, they dynamically are pointing to the same type. The objects they are pointing to are dynamically the same type. Okay, in that case we can do something here called a cast. Okay, let's now move on to here. Okay, let me now again I need to actually do let me see what color do I have. What about blue over here? Okay, reaching this line over here, what does it really mean? Reaching this line, again, it means we didn't return in the earlier three. We didn't return over here, we didn't return here, and also we didn't return here. That's why we can reach this particular line, the blue one. Okay, so what I want to do is I want to say reaching this line, okay, just that line. Okay, over here, I just want to make a note. Okay, reaching this line, reaching this line means no earlier return. Okay, when I say no earlier return, that means we didn't return from here, we didn't return from here, and also we didn't return from here, we didn't return from here, and also we didn't return from here. Let me write down exactly what that means. Okay, that means number one, we didn't return from the first return, this one here. That means this is not equal to the OBJ, right? The negation of the if statement here. If it is equal to, we would have returned, but we didn't return, so that's why it should be not equal to. And number two, for here, so OBJ equals null, that means we're going to return false, but we didn't return, so it should be not equal to null. So that means OBJ not equal to null. And number three over here, we would have returned false if this .get class is not equal to obj.get class, and we didn't return. So that means this must be the negation of that, should be equal. Okay, write it down. So that means number three should be this dot get class should be the same as other dot, oh sorry, not other, I mean obj, should be obj dot get class. It's really important for you to see the control structure over here. So this equals method, even though it's not so many lines of code, but it's very compact. So that's why there are many points about logic that you should really know. That's why I'm really spending enough time to really walk you through every line. Okay. So now, when we can reach this line, what does that mean? That means all the three, right? This and objects are not the same objects, and then also object is not equal to null, and also this and obj, they are both dynamically the same type. Okay, and we're doing something called casting over here, and that's also something I need to briefly touch upon, but we'll give you the complete details later when we spoke about inheritance. Okay, let me use maybe purple over here. So this line over here. So why is this line so necessary? Okay, we know that let's say here if we try to do p1 dot equals p2. Okay, first of all, you can see that what's p2? P2 is corresponding to this particular, let me use purple over here, is corresponding to the objects obj over here, right? You can see the fact that you declare obj of type objects. By the way, whenever you want to declare some variable, the type you declare that to is called static type, right? It's also documented in the slides. I'm just trying to fit every point over here. You can read through the slides separately as well. So the objects over here is called a static type. And the notion between static type versus dynamic type, it will be explained completely when I go to the inheritance. But for today, I just want to give you some intuition. The fact that you declare obj of static type objects over here, okay, simply means any argument type is acceptable, because objects is the most accommodating class in Java, because it's simply the parent class for every class. Okay, that's something you should know. So any argument type is acceptable. Later in the course, we will actually talk about when you actually change the static type for the arguments by the type you change, you might simply constrain the list of possible arguments value you can actually put depending on its type. But in this case, since we put the object, the most accommodating type being the top of the hierarchy for every class in Java, in that case, this obj here can be anything, including P2, which is of type .v2. Okay, good. So let's now talk about this particular example here. Why do we need a cast over here? Okay, let me just say something alternative. Okay, I want you to try something for me in your Java code. Okay, you can see here we simply say return this.x, this.y. That's okay. However, we simply say other.x and also other.y rather than obj.x and obj.y, right? What if we say over here obj.x and also we try to say obj.y? Can they work? The answer is no, they cannot work. Compilation error. Okay, let me try to give you some intuition here. In Java, for every variable, you must declare a type, which is it's a static type. In this case, obj static type is objects. And as soon as the static type is declared, the list of attributes or methods you can invoke upon that particular object variable depends on its static type. If that particular static type, let's say objects, actually has the attributes available, then you can invoke them. But here's a question. X and Y, where did we define them? Did we define them in the object class or the subclass .v2? The answer is we declare them in .v2. So that's why obj over here, since its static type is actually objects, so we cannot actually invoke obj.x and obj.y directly, because the static type objects does not declare the x and y. Okay, that's something very important to note. And how can we address that? Okay, let me just give you some example over here. Let's say we have, let's say when we do P2 over here, right? Let's say P1 that equals P2, right? So you can see obj over here is going to be replaced by P2 over here. Okay, however, P2 is going to replace obj, that's true. However, its static type is going to be objects, as we actually declare over here. So that's why if you simply try obj.x, obj.y, it's not going to compile. Okay, so you can see, think about P2 is over here, it's pointing to this particular objects. So what we should do is do something called typecasting. So what we do is we simply say, cast the obj over here into some type that's guaranteed to give us the x and y attributes, right? In this case, it's a little bit typo over here. So this should not be point, just point. It should be .v2, okay? But if you see the slides, you will see that it's actually fixed, okay? This should be .v2. As soon as you do that, you're basically saying we're going to create an alias called other. And other is also going to point to this particular object over here, but the critical difference is the static type for P2 over here. P2 is only going to replace the obj for the arguments. So P2, let me just put also this information over here. So P2, its static type is actually objects. On the other hand, for other is going to be assigned to the address of this cast version, the cast over here. The cast version for other, its static type is now different. It's going to be .v2. And once you have changed that, you will be able to say other.x and other.y. So that is y. Okay. So guys, I know there's a lot of information over here. I'm trying to summarize everything in one single page. You may just want to rewatch parts of this to make sure you can understand the entire picture. If you got any doubts about any points I said, please ask me in the Google Doc, in the Q&A, or reach out to me. Okay. And I think I've said everything I need to say. You will also see the corresponding points in the slides as well. Let's take a look. Okay, so you can see the cast over here. You can see this is the cast you learned about in the first year. I think in the first year, you only try to cast maybe into double or try to cast into integer. But now we're casting into some reference type. So this is something I will talk about in complete details when I talk about typecasting inheritance lecture later. But for now, you just have to know, if you simply got obj, you cannot, because obj was declared to be objects, you cannot say obj.x or obj.y. You just cannot say that, right? You can try that, it's going to be compilation error. On the other hand, oh, you know what? Why don't I try it together with you, right? Let me just go back to over here. If I go to point V2 over here, okay, you can see this is what we had, right? What if I try? Let me put that into comments. Return this x equals obj, the arguments over here, dot x, and obj, and also this dot y equals obj dot y. If I do that, well, I got compilation error. You can see, let me move the cursor over. X cannot be resolved or is not a field, meaning that x is not recognized as an attribute of the static type of obj, which is objects. Remember I said the x and y are only declared as attributes in point V2. They are not declared as attributes in object class, right? I just illustrated to you on the Eclipse. So that's why you must actually try to cast the obj into this particular type if you are so sure that obj's dynamic type is actually point V2. Indeed, it is, because this is something we having been able to reach this line, we know that this if branch over here must be false, meaning that this .get class, in this case point V2, must be equal to obj.get class, which is also point V2. So that's why you can do the casting over here. Okay, you can see all the logic points actually get connected to each other. So please review this part of the video very carefully. All right, I will just put this into comments over here, and then you can just remember to maybe uncomment that just as an example for yourself. Okay, let's now move on.